find the angle between the planes x minus y plus z equals 1 and 2x plus y plus z equals 0. Round your answer to the nearest hundredth of a degree. If your normal vector to just a generic plane, if your normal vector has components a, b, c, and the plane goes through the point, say, x naught, y naught, z naught, then the equation of the plane, if you watch the video, okay, these guys, a, b, and c, if you remember, become the coefficients of x, y, and z in the equation of the plane, right? So ax plus by plus, well, let's do it this way. Let's do this. This is the easiest way to remember. Ax, we'll call this, I probably called it the standard form in the video. A times the quantity x minus x naught, right? Plus b times the quantity y minus y naught. Plus c times the quantity z minus z naught equals 0. And I really want to emphasize that then if the equation of the plane, whether it's in this form or in the multiplied out form like these are, doesn't matter. If you multiply this out, the coefficients of x, y, and z will still be a, b, and c, the components of the vector that's normal to the plane, right? That's important that you realize. N is a normal vector to the plane. So let's call this plane 1, P1, let's call this plane 2, well, including the equals 0, let's call that plane 2. What would be the normal vector for plane 1? Just looking at it, what would be the normal vector? So just take the what did you do? You just
took the coefficients of x, y.
Yeah, you just took the coefficients. 1, negative 1, 1. Right? So I'll call that n1. The normal vector for plane 1 would be, well, okay, it's not it's really a normal vector because any scalar multiple is also normal, right? Does that make sense? Yeah.
So when you're saying normal vector, what does that imply?
Normal means orthogonal or perpendicular. We've got several words for perpendicular. So if I hate trying to draw this stuff if I'm trying to go quickly, but if you take your time, okay, imagine that's kind of a plane sticking out perpendicular to the whiteboard. It doesn't have to be perpendicular, but just use your imagination. It's in space. Then a normal vector is going to, if you place its tail, say, right on the plane, then it might stick up. So it forms with the plane, it forms a right angle right there. It could also stick down the other way, right? It could stick in the opposite direction. So that's a normal vector. It's perpendicular to the plane. It forms a right angle with the plane. Does that make sense, you guys? Okay, and then what would n2 be? The coefficient's 2, 1, 1. So I'm pointing at the 2 there. I'm not saying it's 1. So 2, 1, 1. And hopefully without trying to make me draw it, does it make sense that if you have two planes and you want to find the smallest angle between them, then that should match the smallest angle between the two normal vectors, shouldn't it? Does that seem reasonable? Yeah. So the idea is if we find and we really are talking about the smallest angle between the planes, if we find the smallest angle between the two normal vectors, that'll be the same as the smallest angle between the two planes. Does that seem too crazy? So yeah, I talk about that in the video. And the equation I come up with in the video, it's just about the same as the equation for the angle between two vectors that we came up in class last week. Or was it the week before? I don't remember. It's the cosine of, it's not quite this. It's not quite, this is what we came up with in class either the first week or last week. I don't remember. Cosine of theta equals n1 dot n2 divided by magnitude. Another formula you need to memorize. Magnitude n1 times n2. That's if they're just two generic vectors, right? But we actually have to take the absolute value to ensure we get an angle in the first quadrant. Because if you draw any two planes, there's going to be a smaller angle between them, right? So that's the formula that I came up with in the video. And so you look at the formula and you just let the formula tell you what to do. What does that formula tell you to do here? Well, I mean, if you look at the numerator, doesn't it just tell you to take the dot product of N1 and N2? Okay, so let's do that. N1 dotted with N2. What's that going to be?
2 negative 1, 1.
2, so 2, we're multiplying that guy, adding it to that guy, which would be addition of a negative. So 2 minus 1 plus 1, right? So 2. And then, okay, what are the magnitudes? What's the magnitude of N1? Yes, square root of 3. Does everybody see that? Square root of 1 squared plus negative 1 squared plus 1 squared. Okay, and then what would the magnitude of N2 be? Square root of 2 squared plus 1 squared plus 1 squared, I think that would be root 6, right? Does that make sense? So if we put it all together in the formula, then we have the cosine of theta is equal to what? Well, absolute value of 2 on top is just 2, right? So we're plugging in there, the 2 into there in for that entire numerator. And then divided by root 3 times root 6, root 18. Which I don't know, if you like simplifying, what would that be? 3 rad 2. I don't think it really helps to simplify it because you're asked to find an approximation anyway, right? So what would you do to finish off the problem then? Inverse cosine. And it will spit out the right angle no matter what, so you don't have to worry too much about a reference angle or anything. So cosine inverse of, it would be easier in your calculator to type in 2 divided by root 18, I think. And I think I said degrees, so could somebody do that for me real quick, just so we have a complete answer here? What is that approximately equal to? 61.87 degrees. Okay. Everybody agree with that? I don't remember what it is. Okay.